So maths words sound super complicated and unnecessarily difficult, but mostly they're just in really old, in ancient languages. So when they're translated into modern English, they're usually pretty straightforward. So I have this thing where I do really like to cover the etymology of the words at some point when I get the chance. In this case, poly just means many. Not sure why it's turned that blue. And that part, there's a few different roots for nomial, but one of them is parts. So a polynomial expression is one that has many parts. A monomial, mono, means one, like monobrow or monocle. Bi means two, tri means three, like triangle, tricycle, two, bicycle. So suddenly these more complicated sounding words are actually pretty straightforward once you translate them into modern English. Just one part, two parts. Let's do that again. Three parts. And when you get beyond three parts, we just call it a polynomial with four terms, with five terms, etc. There is one slight contradiction here which does need to be handled. And it is partly just an artifact of history, but even though a monomial has only one part, it is still considered a polynomial. Mildly confusing, but it's just because history and conventions, and sometimes these slightly weird things happen, but it's no big deal. We could also get into the etymology of linear, quadratic, and cubic. I probably wouldn't here, and that's because while we can talk about quadratic being the Latin word for square, which kind of makes sense because you're looking at x squared terms or whatever the whatever the unknown letter is. And cubic's not so bad because you're talking about things being cubed, but when we get here, there isn't a direct connection between the exponent and what we call it and the word. This makes a lot more sense when you start looking at it in terms of graphs, and you have a linear graph for something like this. So I would probably want to introduce the etymology for these if and when I'm looking at graphs at the same time, just so that I can draw the connection between line and this. The alternative is to talk about it in terms of dimensions. Exponent is 3 and we're in 3 dimensions. Exponent is 2 and we're talking about squares. We're in 2 dimensions. Exponent is 1 and again we're in 1 dimension. We're talking about just lines, but this is meant to make things simpler, not more complicated. So it's a real question of what the class you're working with is capable of understanding, what is going to make sense to them very quickly. These, maybe we cover them here. I suspect I'm covering them later or earlier, depending upon the overall curriculum design.